Alright, so this is the last video for this week. Today we are learning about sample spaces for compound events. If you've been updating your table of contents, we are on page 60. Friday, oh no, dang it, it's not April. May 8th, page 60. And the standard is 7 SP 3.8. So I have practice problems printed out for us, but before we can start them, we need to break down what this title means. What does sample space mean, and what are compound events? So, sample space. Sample space. So both of these terms you'll hear a lot in the future when you're doing probability. So sample space is basically, it's all possible outcomes. So when they say, what's the sample space of, like, look in your closet. What's the sample space in your closet? It's literally every single combination of outfits that you could make. When you go to the grocery store and you're walking down the frozen food aisle, what's the sample space of ice cream flavors? Okay, there's chocolate, there's vanilla, there's Reese's, there's cookies and cream, Moose Tracks, mint chocolate chip. So all possible outcomes. That's the sample space. So we're going to be finding the sample space, all possible outcomes for compound events. So what we've been doing so far in probability was just a single event. You flip a coin, okay? You draw a Skittle out of a bag. Now it's going to be compound events. So you flip a coin and you draw a Skittle out of a bag. You do more than one event. So a compound event two or more events. So very straightforward. Sample space, all possible outcomes. Compound event, two or more events. So you can continue writing your notes down here. I printed out the example problems, so I'm just gonna bring it over here now. Obviously, I don't expect you to write down every single word, just write down the gist of it. So we are going to do 3 problems together, and I didn't really like the Khan Academy assignment for sample spaces for compound events, so there's going to be a 4th problem at the end that you are welcome to do on your own paper, and then text me a picture of it, email me a picture of it, whatever, and I'll give you extra credit if you actually do it and do it correctly. So, example 1. You're picking out water balloons. There are 3 colors and 2 sizes. Okay, so that's important. 3 colors and 2 sizes. The 3 colors are green, orange, and yellow. So we have green, orange, and yellow, and the 2 sizes are large and small. Okay, so I just chose a picture that had green, orange, and yellow balloons. So we have green, orange, and yellow water balloons and 2 sizes. You can either get a large or a small. Use a tree diagram to determine the sample space for the compound event. So you guys have probably seen tree diagrams before when you were doing multiplication, where you might, let me just do it on scrap paper, you might break it down where it's like 6. Okay, well that's 2 times 3, or 12. Okay, that's 2 times 6. 2 is 1 times 2, 6 is 2 times 3, and you keep breaking it down. So that's a type of tree diagram. So we're going to use tree diagrams also for probability when we're finding the sample space. So why is this a compound event? It says 2 or more events. What are the events? And they're not events like birthday parties. It's just like 2 or more separate options. So one of the events is the color. The other event is the size. So first they talked about colors, so I'm going to do colors first. So we have green, we have orange, and we have yellow. Am I even going to try with yellow? Can you guys see that? Hey, you guys kind of can. So we have green, orange, and yellow water balloons. Now, let's say you get green. Okay, you can determine, do you want large or do you want small? Okay, when we get orange, you have the same decision. Do you want large or do you want small? Yellow, same decision. Do you want large? Do you want small? So, the color of the balloon, that's event 1. Okay? The size is event 2. You don't typically need to write this. I'm just writing it so you guys can see why it's a compound event. Event 1, color. Event 2, what size? So, overall, we have 6 different options. You could get green large, so I'll put GL for a green large balloon. Green small, GS, green small balloon. You could get an orange large balloon or an orange small balloon. And you could get a yellow large balloon or a yellow small balloon. So, total we have 6 possible outcomes. So we used a tree diagram. Our sample space are these 6 different outcomes for the compound event. Now, you could do it backwards. I usually just do it in the order that they introduce it. They introduce the colors and then the sizes, but you could have done large, small, and then for large you do. So I'll show you that one. You could have done, let's do it here. You could have done large balloons versus small balloons. And then for large, you could get green, you could get orange, or you could get yellow. For small, you could also get green, you could get orange, or you could get yellow. So both trees are completely accurate, and both trees end up with 6 choices, because this one will give us large green, large orange, large yellow, small green, small orange, small yellow. So both trees end up with the same 6 outcomes. It's whichever one you prefer. Both are accurate. So that is example 1. Example 2. In the morning, Miss Fry either eats a bagel or has a bowl of cereal. To be honest, it's usually a bagel or a smoothie. Okay, so she either, that's the wrong pen, eats a bagel, so we have bagel, or we have cereal. Okay, if she has a bagel, she has to decide between peanut butter, cream cheese, or butter. If she has cereal, she has to decide between Cheerios or Cinnamon Toast Crunch. So first I have, my bagel or my cereal. Then I have to decide, what toppings do I want on the bagel or what type of cereal? And then, I need something to drink. I get thirsty. So for my drink, I have orange juice, milk, water, or coffee. Using a tree diagram, determine the sample space for the compound event. FYI, this is a big one. We're only doing one big one, the next one's small. I just wanted to show you how massive it can get. So, sample space, we got to see all the possible outcomes for this compound event. So first off, we got to decide. I'm going to write small. Does Miss Fry want a bagel, or does she want cereal? Okay, so that's event 1. Which entree am I going to choose? Then, once we choose that, if I choose a bagel, I can get peanut butter, I can get cream cheese, or I might put butter on it. If I do cereal, I might do Cheerios, or maybe I want something sweet and I'm going to do Cinnamon Toast Crunch. So event 1, what was event 1? What was the, oops, that's an A. That's why I don't talk while I write. Okay, Cinnamon Toast Crunch. So event 1 was, what's the entree going to be? Am I going to have a bagel or a cereal? Event 2, basically, what's my toppings? Toppings or flavor, whatever you want to say. So toppings or flavor of cereal. And then the last event is, what's my drink gonna be? So I can have bagel with peanut butter, bagel with cream cheese, bagel with butter, but for all those choices, I still have these 4 drink choices. So I can have orange juice, I'm gonna put OJ. I can have milk. I can have water. Or I can have coffee. But then I have those same options for cream cheese. So let me switch colors just for eyesight choices. So again, it's OJ, milk, water, coffee. And then if I have butter, I still can choose between OJ, milk, water, coffee. But then what if I had cereal? I have the same drink choices still. OJ, milk, water, coffee. OJ, milk, water, coffee. So you have to put these branches on every single choice. So basically, you can have bagel with peanut butter with orange juice, bagel with peanut butter with milk, bagel with peanut butter with water, bagel with peanut butter with coffee. Okay? Or you can have bagel with cream cheese with orange juice, bagel with cream cheese with milk, bagel with cream cheese with water, bagel with cream cheese with coffee. Or you can have bagel with butter with orange juice, bagel with butter with milk, bagel with butter with water, bagel with butter with coffee. Or you could have cereal with Cheerios with orange juice, cereal with Cheerios with milk, cereal, Cheerios with water, cereal, Cheerios with coffee. Or you could have cereal, Cinnamon Toast Crunch, orange juice, cereal, Cinnamon Toast Crunch, milk, cereal, Cinnamon Toast Crunch, water, cereal, Cinnamon Toast Crunch, coffee. Hopefully by the end of that, you're like, Miss Fry, we get it. Like, there's a ton of choices. Okay, so how big is our sample space? How many total options do we have? Well, you could count each one, bagel with peanut butter with OJ, or you could just count the last branches. Because this is bagel with peanut butter with orange juice choice. This is bagel, so it represents it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There were 20 possible outcomes in our sample space. Wow. Next week we are going to learn a shortcut so you don't have to draw out this tree every time, because that definitely gets obnoxious. If you think you know the shortcut, go ahead, try to figure it out. Now, part B. if choosing at random, what's the probability that Miss Fry will have a bagel? Oh, I meant to put with peanut butter and orange juice. So bagel, peanut butter, and orange juice. So probability, bagel with peanut butter and orange juice. So remember, probability. It's the number of favorable outcomes. So basically, how many different options do I end up with bagel with peanut butter and orange juice? That's pretty specific. That's just not like bagel. So bagel with peanut butter and orange juice. Bagel with peanut butter and orange juice was only one of the options out of 20. So the probability that I'm going to have bagel with peanut butter and orange juice, if chosen randomly, is 1 out of 20. Or, remember, fraction means divide. 1 divided by 20 equals 0.05, which is 5% chance. That's actually what I had this morning. All right, here's the last one we're going to do together. If you're feeling confident, you want to try it on your own, go for it. And then play the video when you're ready to check in. So you toss a nickel and then a dime. So you're tossing 2 different coins. The nickel, that's going to be one event. The dime, that's going to be the other event. Use a tree diagram, okay? So we have a nickel and a dime. Use a tree diagram to determine the sample space for the compound event. Sample space, all possible outcomes. Compound event, 2 events. Tossing a nickel, tossing a dime. Use a tree diagram. Okay, so I'm going to say first we're going to do the nickel. So that's our event 1. Now, what are our possible outcomes when we flip a nickel? Well, you could get heads or you could flip tails. Okay, so that's event 1. Easy. All right, but then we're going to flip the dime. Now, dime also has heads or tails. But we can't just put heads, tails. You have to draw the branches from the nickel. We could flip nickel for the heads for nickel, and then flip heads for dime. Or flip a heads for the nickel, and then flip tails for the dime. You could originally flip tails for the nickel, and then heads for the dime. Or tails for the nickel, and tails for the dime. So those are your 2 events, and the sample space is going to be heads and heads, heads to tails, tails to heads, tails to tails. So the first letter represents what you flipped for the nickel, because you tossed the nickel first. The second letter represents what you flip for the dime. So we have 4 possible outcomes in our sample space. All right, what's the probability that both coins land face up? So what's the probability that we get heads and then heads again? So make your prediction. What's the probability that we get heads and heads again? Okay, you might naturally think it's 50% because, well, you get heads half the time. But think about it. What's the probability that you get heads for the nickel? 1/2. What's the probability that you get heads for the dime? 1/2. So you're going to learn next week that when you're doing compound events, the probability, you do the probability of each one. So probability of heads, 1/2, probability of heads again, 1/2, and then you multiply them. 1 times 1 is 1, over 2 times 2 is 4. So the probability is 1/4. And we can check it by looking up here. We only got heads, heads 1 time out of all for outcomes. So what you should gain from this video, guys, is you should feel now more confident about understanding what does sample space actually mean. It's all possible outcomes, and what is a compound event. Okay, 2 or more events. You also should understand now tree diagrams are a very easy visual way to represent the sample space for compound events. And then you can use the tree diagram to find probabilities. So I'm going to post this problem now here, and you can pause the screen on it. You can write it on your own sheet of paper. You can do whatever. So it says you're ordering a pizza and can only pick one topping. Okay, your choices are cheese, pepperoni, or mushroom. And your crust choices are deep dish or thin crust. So using a tree diagram, determine the sample space for the compound event. So just like we did in each problem, create a tree diagram for me and show me the sample space and how many possible outcomes. Then either text it to me, email it to me, etc. My number is 321-804-0767. You can text that to me, or you can email it to me at frynz@scps.k12.fl.us, or just on eCampus. And I'll give you extra credit for actually, watching the video, giving it your best effort, and if you get it accurate. All right, I hope you guys are having a great day, and yeah, this is the last video for the week.